about probability the other day, and we talked about how probability is the chance of something happening, okay? So you take all possibilities in total, and that's what you divide by. You make a ratio of the numbers. So, for instance, we talked about when we were talking about the card hands, I think we said the total number of hands you could have was 52, choose 5, which ended up being 2 million some. So if you take like the last one that was on your quiz that gave you what's the probability of getting 4 kings and 1 other card, and it ended up being 48, then the probability then of getting that particular hand would be 48 out of the 2 million and whatever it came out to be, right? We divide them. Everybody's good on that? That gives me a decimal. If I want it as a percent, then I can move it over 2 times to the right. So what we're going to do is we're going to form these distributions. And what a probability distribution does is it lists every different scenario you would have and what the probability of each of those scenarios would be. So, for example, let's set up 2 dice that we're rolling. You roll 2, is it 2 dice or 2 die? Die. Is 1 die 2 dice? Right?
Yeah, I get it.
2 dice, okay. 2 dice, these are normal, regular, 6-sided, non-weighted dice, just plain old like you get in the Monopoly set. 2 6-sided dice. You want to do a probability distribution of the sum when you roll. So, for example, I roll 2 dice. I get a 1 and a 4. The sum of that would be 5. Okay, so I want a probability. So I want to list all the different possibilities and then the probability of each one of those occurring. Matthew, what are you looking for?
I was looking at the key.
The key's not. It's not done. It's not right. Okay. They're fixing to come on the announcements. I'm going to call X my random variable. That's going to give me the possibilities. If I'm talking about the sum of these 2 dice, rolling just 1 time, what are the possible outcomes that I could have?
6.
No, okay, give me all of them. What possible from smallest to biggest? What possible? 2 through 12, right? Because I could get 2 1s and get a 2. So I'm going to go through 4, 5, 6, 7, 8, 9. This is the hard part. And you're fixing to see why. Now, here's the thing. If this is all possible outcomes, then whenever I'm done, my probability should sum to 1 or 100%. Because if that's every possible outcome, then if I add all possibilities together, I should get 100%, right? Are you all with me on that? Okay. Also remember, probability can never be negative, and it can never exceed 100%. So let's think about this. How many different scenarios are there when you roll 2 dice? 36, are you sure?
No, I'm not sure on this.
I'm gonna go with Ham. 48. No, 64.
Banks is actually right.
36 sounds good.
Let's think about this. We're going to set up what we call a probability tree. I'm going to do it, instead of doing it vertical, though, I'm going to do it horizontal. My first dice could be a 1, a 2, a 3, a 4, a 5, or a 6, right?
You got 6 things that can go on one side.
Exactly. Times the 6 that could go on the other. It's an and 6 on the other, so it's multiply. So here, but the question is 5, 6. So this, I could get a 1 on the first one and a 1 on the second one. I could get a 1 on the first one and a 2 on the second one. Do you see where I'm going with that? Okay, so then if I rolled a 2, I could get a 1 through 6. If I roll a 3 on the first one, I could get a 1 through 6. And so on and so forth. And I'm just going to set this up. This is what we call a probability tree. You'll have one like this on your quiz. You'll have one like this on your test. Although it might not be the sum of 2 dice. Why aren't you writing this down, Ben? This is notes, notes, notes. So whenever I talk about the sum, okay, the sum of these. So this would be 2, a 1 and a 2 would be a 3, 4, 5, 6, 7. 3, 4, 5, 6, 7, 8. Do we see where these numbers are coming from?
Yes.
I'm adding together. Okay. 9, 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. Or 7. Come on. And 12. So those are all my possibilities. Because remember, I asked you for the sum of the 2 dice that were rolled. So all my possible outcomes are listed there. And in fact, Banks, there are 36 possible outcomes. Okay. So now as I look at this, I want to know what's the probability that whenever I roll it, I get 2. There's only 1 2 up there. So 1 out of 36. So this would be, and probability can be expressed as a fraction or a decimal or a percent. So this would be 1 out of 36. There's only one way to get 2, and that's if you roll 2 ones, right? But now if I look at 3, I see 1, 2, right? I can roll a 1 and a 2 or a 2 and a 1. There's no other way to get 3. That's it, right? So 2 out of 36. Is this making sense to you? Huh? Yeah. So when I'm done, I should have, my whole bottom should sum to 1 or 100%. What'd you say?
I said 7 has the most.
7 has the most?
Yeah, I know that because I gamble a lot.
So what? Let's finish our probability distribution. Are y'all done with this one? This table? This chart? Tell me when you got it. Banks. How many times? Oh, looks like Banks is in your category too. He doesn't have any notes on his desk either.
Okay. Top 3, no notes. Top 3.
4, Banks. How many times can you roll 4? How many ways? Well, if you had your notes, you could look back and reference that. It's 3.
It goes all the way out the same.
All right. Shh. How about 5? How many different?
4.
4.
And then 6 is 5, and then
7 is 6, 8 is 7.
And then it goes
5, 4, 3, 2, 1.
6, 5, 4, 3, 2, 1.
5,
4, 2, 3,
What?
1.
4.
Why does it just start to go down after 7?
Because
No,
7
it's
is the
2.
lucky number.
And
it's smack.
It should be 3.
That is the big trend.
Oh, yeah. It is.
All right, so look, my question to you is, does all of that add to 1?
Yes.
Does it?
Yes.
3, 6, 10, 15, 21, 26, 30, 33, 35, 36, yes.
Yeah.
Okay, so there's the probability. All right, so you're a betting person.
7.
You're rolling. Where's your best bet?
7.
7. Okay. We're going to use this to form a histogram. Do y'all remember histograms? A bar graph. How about that? Easy. We're going to take, but we're going to do it with bars. So what we're going to do our probability on this side. We're going to do our possible outcomes along the horizontal axis. Our possible outcomes are, remember, 1. Oh, not 1. You can't get a 1 when you roll 2 dice. Ha. 2, 3, 4, 5, 6, all the way up
To 12.
to 12. On my probability side, I think I'm going to go by 36ths. 36ths. So this would be 1 out of 36, 2, 3.
Ooh.
Smart. What would this one be?
Now, when does it start to go down after? Is it 5?
7.
Dang.
Ben, 7's in the middle. So.
Okay. So 2, the probability of getting 2 was 1 out of 36. I don't know why that did that.
I take
And
notes
then
sometimes just to get.
3,
Yeah, so he's in the notes column.
no, 4, 5.
I realize.
Whenever I take notes, it even worse. I took notes on the last thing. I did terrible on it.
Ooh, I'm going over too far.
We don't get that from the last one.
2, 3, 4, 5, 6, 7. And then 8, 9, 10. This is the crappiest bar graph ever, but you get the point that I'm getting to. The shape of this is what we call symmetrical because it's equal on both sides, right? If you cut it down the middle, it would be the same. So we call this shape. We describe the shape of probability distributions. This one is symmetrical. Do you see why it's symmetrical?
Yeah, because it's
Okay.
symmetric.
Dude, that's so like we went.
There are 2 other. There, yeah. Thanks. Skewed is whenever I have a distribution that kind of tails off to one side. Okay, you can tail off to the left or to the right. The way in which it tails off is the way in which it is skewed. So this would be skewed right. This would be skewed left. Okay, so on your test, on your quiz, on your homework, you'll be given a probability distribution. You'll be asked to complete the probability distribution, graph the probability distribution, and describe the shape of the probability distribution. Okay? All right. So there is a special type of probability distribution that we're going to kind of zero in on. That special type is what we call a binomial. That was called probability distribution.
What does nomial mean? I hear that a lot.
Binomial means that there are 2 possible outcomes. We call them in general, we call them a success or a fail, a yes or a no, it works or it doesn't work, okay?
Maybe,
2 outcomes.
It's maybe like
Each trial that you have, or each time you do this, like if I'm talking about rolling the dice, that's a trial. Each trial that you do is independent of the other one, meaning what you do one time doesn't impact when you do it the next time. If I roll those 2 dice and then I roll them again, the first roll doesn't impact the second roll at all, right? They're independent of each other, okay? So that's what binomial distributions do. So if they fit this, this situation, think of like a coin being flipped and I'm looking at if it lands on heads. That's definitely binomial. It either does or it doesn't. What's the probability that you flip the coin one time it lands on heads?
Like 75-50.
50-50, right? 50% chance that it lands on heads. All right, so to find the probability, remember we had that P of X on our probability distribution?
yeah.
I'm going to call it P of K here. K is my number of successes. So let's say I flip that coin 100 times. I want to know the probability of getting 16 heads. My K would be 16 there. How many times can I get a successful number of 16 heads? All right, so the formula for this. In trials, K successes. NCR. Actually, I guess we need to change that to K since we're using a K. P is my probability of success. raised to the k times 1 minus p. So this is giving me my probability of non-success. N minus k, yes. This is a k, this is a k, and this is a k. Let me do just one example first, and then we'll actually do a probability distribution together, a binomial. You have a 20-question multiple choice test. There are 5 answer choices for each question. Okay? How many do you need to get right to pass?
What's a passing grade?
60. So,
No, what? You need to get 12 right.
need to get 12 right?
Yeah.
So what I want to know is what's the probability, and we'll just say making exactly a 60. This is not a 60 or better. What's the probability of randomly guessing and making a 60? Okay? So that means my K needs to be 12.
140.
Okay? You got to use binomial because, listen, this is why it's binomial. If you're randomly guessing, you either get it right or wrong, yes? You pick the right one or you don't pick the right one. What's the probability that you pick the right one?
50%.
No, 5 answer choices. 20%, right? So you got a 20% chance on each one. That's my P. That thing is so aggravating. Point 2.
Take it down.
My K is 12. My N, or my total number of trials, or my total number of times is what? 20. So I do the formula, and you got to be careful. This is strictly calculator, but I want to see your formula set up. 20 choose 12. I'm going to multiply that by 0.2 raised to the 12th. And then 1 minus 0.2, which is 0.8 by what's left, which is 8. Okay. Look back at that original formula. It's N minus K.
How'd you get the what's on? Wait, oh, 12 is 8.
Remember the formula? N, C, K, P to the K, 1 minus P to the N minus K. Okay? It is literally a plug and chug formula. Somebody plug it in and tell me what you get. Ben, put that away. Somebody plug it in, plug it in, plug it in. Put, you may want to, as you put this in your calculator, put parentheses here.
Parentheses are like, I hate parentheses.
Somebody tell me what you get, what you get, what you get. We'll stay here till you do it. Doesn't bother me.
Come on, Josh, go quicker. Was, and I was laughing. Nobody wants to do it.
Everybody's like sitting there staring, but when y'all have a quiz on this tomorrow and you don't know how to do it,
Seems like it's hard to type into
I
a
don't know if I got
calculator.
this.
what you
I
get?
don't know if we can do it on this calculator.
You can.
Josh, you got this. Come on, Josh. Josh, you
What?
Scientific notation, so you have to move the decimal left 5 times. Okay? Now,
Good work, Jacoby Johnson.
that is understand, guys. Matthew, please. Understand if I'm on a multiple choice test, if I'm setting up a probability distribution here, what I really have, this would be my K and my probability of K. I could make a 0, a 5, a 10, because they're 5 points apiece, right? A 15, a 20, all the way up to 100. So then, by all means, y'all finish your conversation. So then if I wanted to know what the probability of making a 60 or better would be, I would have to add from 60 all the way up to 100. That would be the probability of randomly guessing up to 100. Let's do a whole distribution together. That one would be way too long to fill out.
So the chance.
I just did one particular spot in that one for you, which would be a 60. That would be like a 0.009% chance,
Would
yes.
that be like a skew to the left, or would it be symmetrical?
It's definitely not symmetrical. It would be, yes, skewed left. Yes.
Zero would just never happen. It would basically.
To make a 0 or to make 100?
To make a 0.
Better chance of making a 0 than 100 because you've only got a 20%, you've got an 80% chance of guessing wrong on each one. It's interesting to do a whole probability setup on that with multiple choice. And on your homework, you have quite a few of those. You have quite a few heads, tails, quite a few multiple choice tests. Let's do this one together if you'll listen with me. According to a survey, about 41%, this is a dumb scenario, but it works just the same, of U.S. households own a soccer ball. You asked 6 randomly chosen households.
Depends where you live.
You asked 6 randomly chosen households whether they have a soccer ball. Make a binomial probability distribution of the results, okay, of what your chances and your probabilities are. So when I ask them, I could get 0 have a soccer ball, 1, 2, 3, 4, 5, or 6. So remember, this is you have to be able to recognize binomial. This is binomial because you either do own a soccer ball or you don't own a soccer ball, okay? So when you set this up, this is my P, right? Because that is the percent of success. 0.41 though, okay? 6 is my N. So this doesn't change, and this doesn't change ever in the problem. What's changing is the K each time, okay? So let's have these 2 rows compute 0. Actually, these 2 do 0. Y'all do 1, y'all do 2, this side do 3, 4, 5, and 6.
Yeah, 4, take up.
So we can do this quickly. Each row only had to do one particular number. So for 0, I'm doing 6 choose 0 times 0.41 to the 0 times 0.59 to the 6th. What did you get?
They got .042.
0.042. We're going to round it off 3 decimal places if we
I
can.
don't know if it's right.
All right, how about 1? What did this row get for 1?
I got 0.175.
0.175. How about 2? .3. I'm gonna go. Give it to me 3 decimals. 306. That's correct. How about for 3? 283. How about for 4?
3.8.
No. You didn't even have 4.
I was guessing.
Who had 4? What'd y'all get for 4? That's correct. Round it off, those that round up to 8. How about 5? What'd you get?
0.21.
041, that is correct. How about 6?
I got -5.9, but
Should be 0.005. As a decimal, yeah. All right, look. You have to, you have to be able to do these to form the distributions. Guys, I'm not done. Y'all thought I was playing. I will get done. You will also have to do a distribution for these, okay? You will graph these up. Look at your highest. This is 0.3, so I would go up maybe by 0.05, 0.1, 0.15, 0.2. If you were a betting person, what is your most probable outcome?
2.
2. If you had to guess when you graph this, thinking about how it goes up, 0.042, 0.175, 0.306, 0.2, 0.1, 0.000, which way do you think it's skewed, or is it symmetrical?
Skewed to the right.
It's going to be skewed to the right. To the, yes. Guys, shh. Your homework is written on the board.